What's up, guys? For those of you who don't know, my name is Dylan, and this is part one of the twin traction beam swap on my 4Runner. In this video, I'll be taking the stock Dana 44 beams I pulled from the junkyard and converting them to plus 4.5 extended beams. Along with the extension, I'll be swapping the inner bushings to Uniballs and heavily plating the beams to make sure they hold up. Twin traction beams are known to bend and crack with heavy wheeling and jumping, so I wanted to be proactive about it. But first things first, I have to remove all my current suspension and delete the factory cross members, so I'm ready to start designing the new beam swap cross members and steering components. I chose twin traction beams because of the large amount of reliable suspension travel while still maintaining four-wheel drive. I ran my four-wheel drive race kit I built and designed from scratch for about a year and a half, and for what it was great. But I was constantly on the limit of what my stock front diff and axles could handle while still not having as much travel as I would like. The kit cycled about 15 inches of four-wheel drive travel, and while that was a lot for an A-arm setup, it just wasn't enough to go do the things I want to do. I was always having to drive it at the absolute limit of its capabilities, which was hard on it. With the new beam setup, it should be around 19 inches of reliable four-wheel drive travel without pushing it to the limit. In addition to this, the Dana 44 beams I chose have a bigger, stronger front diff and axles. This should lead to a much more reliable setup, not having to push it as far to do the same things. Now that I got the factory cross members out of the way, I can start working on the beams. One of the Achilles heels of twin traction beams are the factory inner bushings. They're fine for stock driving and stock travel, but once you increase the suspension travel along with some aggressive driving, they tend to not hold up. To mitigate this, people swap in a spherical joint, aka a Uniball, which is much stronger and will hold up better long term. So I need to drill out that old bushing to put in a Uniball. But I was finding when I was using the hand drill, it was walking all over, as you can see. So got it set up, jigged up in the drill press. We'll see how it goes. What's up, guys? Welcome back to the Bu Built YouTube channel. In today's video, I'm going to be cutting and extending these Dana 44 beams. I already finished extending the passenger side beam. If you guys don't know, all you do is you make a cut near the very end where it's the widest, and you add whatever material you need. So if you want to extend it 4.5 inches, you add obviously 4.5 inches. And this one came out really well. You could barely tell it was there. I blended in pretty well. And I'm gonna be adding gusset plates to the outside to strengthen it all up. So it is, it's butt welded with a good chamfer or bevel. But then it's gonna get a bunch of gusset plates, and yeah, it should be super strong. In order to make it super easy to replicate, my cut line is right halfway through the bolts. So it was for the, the radius arms. These bolts were for the stock radius arms. You can see up there too. And I'm using a different radius arm setup. It's not gonna go right through the beam this time, or on my setup. So my cut line, I made it right through the center of the bolt. So on both the passenger and driver, I'll get them in the exact same place. So I got these plates purposely cut out to extend the beams, something like that. But I didn't factor in, I want it to be a little narrower so I have a perfect weld seam in between each plate. So I gotta trim a little bit off each one of these and then get it all tacked up. Since this piece is just getting butted up right against there, we need to bevel both the edge on the beam and the edge on this 1/4 inch plate so we can get deep penetration. I'm also gonna be welding the inside of this, so it'll be super, super strong, but it's very important to bevel this when you're making a joint like this. So this is what that bevel looks like. If you can see that, it allows for a bunch of penetration, bunch of weld when you're using really thick plate. You can see it right there and right there. So while this may look a little silly, I needed to get this surface perfectly level so I can put the plate down and start building the structure. And obviously I'm gonna make it square and check all the straightness and all that, but I just needed a baseline somewhere to make that flat so I can tack these things together and not try to hold it and do all that. Unfortunately, I don't have a chassis table, so this is gonna do. I propped up my drill press to perfect height for this table. I'm gonna tack it in place and I'll show you the results. All right, so this is the start. As you guys saw, I checked it with a square a bunch of times. It is perfectly square, in line with that beam. Got a couple tacks, and I'm gonna start building the sides up. Get it all tacked together, then I'll weld the inside, and then fully plate the top and put the side on. So we're getting closer. I just need to keep confirming everything is square, pretty solid. Yeah, I need to move the bottom piece up, cut a tack, but shape is starting to get there, starting to take shape. All right, I got everything tacked up, all straight. So I'm gonna weld the outside, then weld the inside of this, and then put on the other side of the beam, weld the inside of that, and then put the top plate on. The reason I'm doing it that way is when this beam flexes, and when you, let's just say you're full compression, like you jump it, you go full compression, smack the bump stop up top, you're gonna put the most force on the bottom, like the pulling force. It's gonna try to pull these things apart. So while probably these welds will be just fine, for the peace of mind of it, I'm gonna weld the inside of the bottom and then put the top plate on at the very end. At least that's how I think about it. I'm gonna go weld that. Not the prettiest welds inside, but just needs to be hot and strong. So we got everything tacked together. We got the knuckle with the extended pieces, and that's kind of what, here, I'll pull my phone off this. That's kind of what it looks like. Here's the inside. I'm gonna be able to weld the inside of that as well, and then I'll put the top plate on. But that is what it looks like. We're getting close. I got the top plate tacked in, ready to get fully welded. It's kind of a shame to be grinding some of these welds, but there you go. All right, so I got it completely welded up. Now I'm gonna smooth it all down. I made everything perfectly in plane so I can grind it all down, and then I'll have some overlay gusset plates to go over this. Should be good, should look like it never happened. After I finished extending the beams, next up was to continue plating them. I am most concerned about the driver's side beam because it is the longer one, which gives it more leverage to bend, and because around where the diff mounts is just a flat piece of 3/16 sheet metal without much structure. To mitigate this, I'm adding another 1/4 inch plate to the bottom of the beam to hopefully give it more structure and act as a bash guard when off-roading. Since I don't have a metal roller, I use the TIG torch to heat up the 1/4 inch plate to bend it around the contour of the axle. I have used this technique several times, but never on anything this thick. Safe to say it works pretty great. Dang, that works better than I thought it would. Bending 1/4 inch plate like that's pretty crazy. All right, I'll show you guys how I did it on the other side, now that I proved it works on this side. All right, so this is the bottom of the driver side twin traction beam, and I want to add like kind of like a skid plate for the bottom and give it more reinforcement. So this is just thin wall, 3/16. It's gonna be bashed on rocks, and there's nothing supporting it going down. The pumpkin goes in here, but it doesn't support that that edge at all. So I wanted to run this piece of 1/4 inch over it for like a skid plate and a bash guard. And I need to bend it around this radius. And obviously can't bend it by hand. If I hit it with a hammer, it would start to bend, but it wouldn't get all the way around on that curvature, because that is a pretty gnarly curve. So on this side, what I did is I took a TIG torch and heated up a line, as you can see a section, smacked it with a hammer, bent it in, and did that a couple times, and it perfectly got around the curvature. You guys probably just saw that. So I'm gonna do it on this side, and I will walk you guys through it. So first, right where I see the gap start, like right about there, I'm gonna heat it up with a TIG torch, and I'm gonna bend it and repeat. Alright guys, that's all I have for you for this video. In part 2, I'll be getting the beams mounted to the 4Runner and cycling them for the first time. Thanks for watching, and subscribe for part 2.